So hello students, today we are going to learn part 12 of trigonometry of class 10. In this part we are going to learn some examples on trigonometric identities. Already we have started this topic, so let us start some examples. Now here we have our first example as we have to prove that cosec theta minus cot theta bracket square equals to 1 minus cos theta upon 1 plus cos theta. Okay. Now for us it will be easy to consider LHS and reach up to RHS. Okay. So first we consider LHS. Okay. So here now we'll write LHS equals to. So now what is our LHS? So LHS equals to cosec theta minus cot theta bracket square. Now what we are going to do? We know that cosec theta equals to 1 upon sin theta. Okay. It can be seen from here. Okay. Cosec theta equals to 1 upon sin theta and cot theta equals to cos theta upon sin theta. These two relations we are going to use over here. Okay, so what we get in the next step? Now instead of this cosec theta, what we will write here? 1 upon sin theta. Okay, so instead of this cosec theta, we have 1 upon sin theta. Now instead of this cot theta, we will write cos theta upon sin theta. Okay, so you get cos theta upon sin theta. Now it can be seen that both this term and this term are having same denominator. When the terms are having same denominator, we can write the numerator only once. Okay, so in next step now this will become 1 minus cos theta upon sin theta. Okay, so the numerator will become 1 minus cos theta together divided by or upon sin theta only once we will write over here. Okay, now this square sign, it is for both the numerator also and for denominator also. So we will give this 2, that is bracket square, for individually numerator and denominator. So when you write it for numerator, we get it 1 minus cos theta bracket square, and for denominator it will become sin square theta. Okay, remember that this square is not written over here, we write it here. Okay, as now this 1 minus cos theta bracket square means 1 minus cos theta is multiplied 2 times. So we get it in this way. Now this sin square theta. So we have an identity. Okay. What identity we have? We have that sin square theta plus cos square theta equals to 1. So from this we get sin square theta equals to 1 minus cos square theta. It means that instead of this sin square theta, instead of this sin square theta, we can write 1 minus cos square theta. Okay, now this 1 minus cos square theta means 1 square minus cos square theta, which is of the form a square minus b square. Let me write it here. So here for this one we can use a square minus b square. Okay, now what is a square minus b square? So it is a plus b in another bracket a minus b. Okay, so now this numerator will remain as it is. Instead of this 1 minus cos square theta, we will write 1 plus a plus b means 1 plus cos theta and 1 minus cos theta. Okay, so we get it in this way. Now it can be seen that these both are multiplying to each other and these both are multiplying to each other. So now here we have 1 minus cos theta, 1 minus cos theta. So let us cancel it now. When we cancel it, we get now 1 minus cos theta upon 1 plus cos theta. Okay, as this one. Okay, now this is nothing but what? That is our RHS, which we have to prove over here. So hence we have proved that 1 minus cos theta upon 1 plus cos theta, that is nothing but equal to RHS. Hence it is proved. Okay. Now let us consider one more example. Now in this example we have to prove that cos A upon 1 plus sin A plus 1 plus sin A upon cos A equals to 2 sec A. Again same condition, from this RHS we cannot reach up to this LHS, so we will consider LHS first. Okay, so here LHS equals to, now what is our LHS? As it is, we have copied over here. Now what can we do? Now we can do cross multiplication. This cos A will multiply to cos A, this 1 plus sin A will multiply to 1 plus sin A, and this both will multiply to each other. That is what we have done. We are taking LCM of that one. Okay, so in next step, after doing the cross multiplications, we get it in this way. Now cos A into cos A will become cos square A. 1 plus sin A into 1 plus sin A will become 1 plus sin A bracket square, and these both will multiply to each other in this way. That is cos A in bracket 1 plus sin A. Okay. Now already we have seen this 1 plus sin A bracket square means it is of the form, I'm just writing it here, A plus B bracket square, which can be written as A square plus 2AB plus B square. So instead of this, we will apply this formula over here. So when we apply that formula, we get now this cos square A as it is here. Then this 1 square 1 plus 2 into 1 into sine A that we have written over here, plus now second term square, that is sine square A. Okay. Now denominator will be as it is. We are not going to make any change in that one. Now in next step, this sine square A and cos square A we can write it together. Okay, so what do we get? We get it as sine square A plus cos square A plus this one as it is plus this 2 sine A. Okay, now we have already seen that sine square A plus cos square A is equal to what? 1. That is an identity which we have seen up. Okay, so instead of this sine square A plus cos square A, what we will write? We will write there 1 and remaining terms as it is. Okay, so now instead of this one, we have written here 1. Okay, now plus what we get? Instead of this 1, we have written here 1 plus 2 sine A as it is here 2 sine A. Okay, now the denominator will be as it is. We are not going to make any change in the denominators. Okay, now this 1 plus 1 will become 2, remaining terms as it is. Okay, so we have here instead of this 1 plus 1 we have here 2, 2 sine A, we have 2 sine A. Now it can be seen that both these terms are having 2 as a common, so we can remove that 2 common. When we remove 2 common, we get, now what do we get? This 2 out of the bracket, inside the bracket 1 plus sine A. Okay, denominator as it is. Okay, now it can be seen that here also we have 1 plus sine A, here also we have 1 plus sine A, so we can cancel that 1 plus sine A. Now in next step, what we will get? We'll get 2 upon cos A. Okay, now it is nothing but, or it can be also written as 2 into 1 upon cos A. Both are correct. Now what is 1 upon cos A? So we have seen earlier 1 upon cos is nothing but it is equal to sec A. Okay, so our next step answer will be, that is 2, this one as it is, into 1 upon cos A means sec A. Now what is this 2 sec A? That is nothing but our RHS that we have to prove. Okay, so finally what we get? Our answer is equals to 2 sec A, which is equal to RHS. Okay, hence we have proved that LHS equal to RHS. Hope you all must have understood up till here. So this much is enough for today. Thank you. Have a nice day.